everyone, welcome to Huawei Storage Info TV, and today we will be discussing the OceanStor Pacific 9950, what it is, and how to remove and insert different modules. The OceanStor Pacific 9950 is a 5U high-density all-flash storage device developed based on Huawei Kunpeng 920 processors that delivers superb storage performance. It adopts a multi-node design within length, width, height specs of 926 by 447 by 219.5 millimeters. The chassis weighs 115 kilograms at full configuration, offering a maximum operating power consumption of 3,500 watts. Our flagship product supports 8 independent storage nodes, with each node supporting 10 half-palm NVMe SSDs. In total, a single device supports a total of 80 half-palm NVMe SSDs. If not fully configured with nodes, you need to install assistant cooling modules into the vacant slots for heat dissipation of the data cluster modules at the rear of the chassis. The rear view of an OceanStor Pacific 9950 chassis includes 2 data cluster modules, 16 interface modules, and 4 PSUs, and a maximum of 6 PSUs can be configured. If the chassis is not fully configured with nodes or I/O card modules, you need to install filler panels in the vacant I/O card module slots or heat dissipation. Next, let's look at the modules from the front view. Each of the 8 nodes is configured with one Kunpeng 920 processor, and each processor supports 8 DIMMs. Each node supports 10 half-palm NVMe SSDs as the main storage, 1 BBU for battery-protected memory, 4 counter-rotating fan modules for heat dissipation, and 2 M.2 SSDs as system disks. The 8 nodes in a chassis are numbered 0 to 7 from left to right. To remove a node, first press the release button on the node, fully raise the ejector levers, and then pull the node out. You will notice indicators on the upper part of each node. From left to right, they are power button and running indicator, location indicator, fault alarm indicator, and the built-in FRU alarm indicator. When the node is running properly, the running indicator is steady green. When the node is being located, the location indicator is blinking blue. If there is a fault on the node, the fault alarm indicator is steady orange. And if an FRU in the node is faulty, the built-in FRU alarm indicator is steady orange. On the right of the node, disk slots are numbered 0 to 9 from left to right. To remove a half-palm NVMe SSD, first press the release button on the half-palm NVMe SSD to automatically eject the ejector lever. Then, hold the ejector lever and remove the half-palm NVMe SSD. Half-palm NVMe SSDs are dedicated storage media designed by Huawei for high-density flash storage. The Huawei models take their name from their small size, with a size smaller than the size of your palm, offering specs at 9.5 mm thick by 38.4 mm high. By contrast, traditional 2.5-inch SSDs are 37% thicker and the 50% taller than our models. This minimal size enables an OceanStor Pacific 9950 chassis to accommodate 8 storage nodes in the 5U space and support 80 half-palm NVMe SSDs as the main storage of the storage system. There are also indicators on a half-palm NVMe SSD. One is a running indicator and the other one is the alarm location indicator. When a half-pan NVMe SSD is running properly, the running indicator is steady green, and this changes to blinking green when data is being read or written. In the event that a half-pan NVMe SSD is faulty, the alarm location indicator is steady orange. When a half-pan NVMe SSD is being located, the alarm location indicator is blinking orange. When installing a main storage half-pan NVMe SSD, open the ejector lever and slowly push the half-pan NVMe SSD into the slot until it can no longer move forward. Then simply close the ejector lever and voila, you have installed your half-pan SSD. A BBU is under the main storage disk modules. To remove a BBU, hold down the release button on the BBU and slowly pull it out. In fact, during maintenance, you don't need to remove the node when replacing a BBU. BBUs supply power to nodes in the event of an external power supply failure, while CPUs in nodes store data in the battery-protected memory to half-pan NVMe SSDs. This prevents data loss in the event of a power failure. The BBU has indicators. When steady green, the BBU is fully charged and running properly. It turns blinking green when charging and steady yellow if there is a fault. If you are wondering what battery-protected memory actually is, don't worry. We will introduce it later when we talk about DIMMs. To install a BBU, push it into the slot with the side with the indicator silk screen facing downwards until you hear a click. To introduce DIMMs, you need to remove the node cover. Before removing the node cover, ensure that all indicators on the front panel are off. This indicates that all data in the battery-protected memory is written to the half-pan NVMe SSDs. There is a CPU and multiple DIMMs. To remove a DIMM, first fully open the fixing clips at both ends of the DIMM. Then you can pull it out slowly. Because each node supports 8 DIMMs and each DIMM provides 32 GB memory capacity. Theoretically, a single node can provide a maximum of 256 GB memory. In the 256 GB memory, 32 GB memory is used as a battery-protected memory. This data is separated from the main storage data and is designed to store and restore data quickly. After data is written to the battery-protected memory, the system automatically saves and restores the data from the battery-protected memory upon node power off or system restart. In addition, the system checks data consistency to ensure proper service running. When installing a DIMM, place it vertically in a slot and press down both ends of the DIMM. When you hear a click, the fixing clips at both ends of the DIMM are locked, indicating that the DIMM is properly installed. Fan modules are located inside a node, and each node is configured with 4 40mm counter-rotating fan modules working in N+1 redundancy mode. When removing a fan module, press the latch on both sides of the fan module and hold down the release button to unlock it. Then, you can easily lift the fan module out of the chassis. Each fan module has 2 rotors. One rotor has 5 fan blades, and the other rotor has 4 fan blades. The air flows from the front to back. Then, the airflow generated by the rear rotor is boosted again by the front rotor. This dual fan module design increases the air volume within the high voltage system, enhancing the overall heat dissipation of the entire high density system. When installing a fan module, insert it along the slot and then press it until you hear a click. This indicates that the installation is successful. Behind the 5 modules are M.2 SSDs. To remove an M.2 SSD, press the latch to unlock the M.2 SSD and slightly tilt the M.2 SSD upwards, and then remove it. Each node is configured with 2 M.2 SSDs, which are used as the system disks to boot the operating system, and configured read-1 mode. The system disk on the right is numbered 0, and that on the left is numbered 1. When installing a system disk, tilt it by 20 to 30 degrees, insert it into the slot, and then press the latch. Now, let's install the node back into the system subrack. First, install the node cover. Place the cover into the node slot, and then push the cover inwards. To install the node, fully raise the 2 ejector levers first, and then slowly push the node into the system subrack. When the ejector levers touch the chassis, you can release ejector levers, and the node is automatically fastened to the slot with the force of the ejector levers. When you hear a click, the node is successfully installed. Finally, let's talk about modules on the rear panel of an OceanStor Pacific 9950 chassis in detail. From the rear view of the chassis, we can see that there are 2 data cluster modules in the upper part in slots A and B. The 2 data cluster modules work in 1+1 redundancy mode. When replacing a data cluster module, rotate the release buttons on both sides to unlock these ejector levers. Hold the levers and then pull the data cluster module out of the system subrack until it no longer moves. Then, press the release latches on both sides to completely unlock the data cluster module, and then remove the module from the subrack. Let's look at the ports on the panel of a data cluster module. From left to right, they are the serial port, BMC management network port, and NIC port. The 8 LOM optical ports from right to left correspond to node 0 to node 7. The serial port is used for function extension of the operating system and third-party software. The BMC management network port is a GE port and mainly used to monitor and manage hardware in a highly reliable manner. Likewise, the NIC port is also a GE port and used to access device manager or query the alarm information about the data cluster modules. The LOM optical ports are 100 GE ports that connect to the back-end cluster communication network. The LED displays the chassis number. The indicators on the right are the running indicator and the fault indicator, respectively. When the data cluster module is running properly, the running indicator is steady green, but if it encounters a fault, the fault indicator is steady yellow. When installing the data cluster module, hold the ejector levers on both sides of the data cluster module and push it into the system subrack until you hear a click. This click indicates that the module is in place and successfully installed. The area on the rear panel corresponding to the data cluster modules is for I/O card modules. The I/O card modules connect to the service network or front-end storage network. OceanStor Pacific 9950 provides 16 I/O card modules. Every 2 I/O card modules correspond to 1 node. For example, from left to right, these 2 I/O card modules correspond to node 0. To remove an I/O card module, simply press the release button, hold the ejector lever, and pull it out. Note that before replacing an I/O card module, you must power off the corresponding node. There are 2 types of I/O card modules: ID I/O card modules, which are either 100G EDR or HDR 100 models, and Ethernet I/O card modules, often 25GE or 100GE. There is only one indicator on an I/O card module. After the I/O card module is powered on, the indicator is steady green. To install the module, simply push it back into the slot until you hear a click. During maintenance, after installing an I/O card module, you need to press the power button of the corresponding node to power it on. OceanStor Pacific 9950 supports 4 2000-watt PSUs in slots 0, 1, 4, and 5 respectively. The 4 PSUs work in 2+2 redundancy mode. To remove a PSU, press the latch and hold the handle on the PSU at the same time. Then, pull the PSU out of the slot. The PSUs are standard 68mm platinum PSU that provide a maximum conversion efficiency of 94%. Each PSU provides a maximum of 2000 watt power. Each converts external AC power supply into the internal power voltage. This is the PSU indicator. When working normally, the indicator is steady green. However, if a PSU encounters an exception or input over voltage or over current, the indicator changes to steady yellow. To return the PSU or install a new one, simply push it back into the slot until you hear a click. The maintenance for OceanStor Pacific 9950 is as easy as that. That's all for today. Thank you for joining me and see you next time.